mic on?
Nope.
Check the switch. Oh, somebody turned it off. That's the problem when you got software guys. So I think most of you know me. I'm Zach Erlacher, VP of Products at MySQL. I had Kai Arno asked me to mention at 10:30 at the break, there will be a meeting of the secret Jonathan Schwartz Lookalike Society. So if you're thinking of a ponytail or your alpha or beta in your ponytail process, come on by. One of the topics that's obviously very important to MySQL users is backup. It's something that people feel very passionate about. I remember about 2 years ago, so I'll do this again. 2 years ago, I had a meeting with Monty, David, Martin, and some other folks, and I said, you know, we really need to have a team focused on backup. We've been talking about this to users and customers for 3 years, and we just got to do better. And then Monty put up his hand and he said, no, Zach, we've been talking about this for 7 years. I said, okay, we really got to get this going. So we put a focus team at that point, and it was sometime after that I met Chandler from Zmanda, and he came to meet us at MySQL. He told us what they were doing. I thought, oh, thank heavens, because it's really great to have a community and an ecosystem that helps work with MySQL and fill in some of the gaps and shortcomings, because we can't do all the developments ourselves within MySQL. So we got to meet many of the folks from the team, TK, Chandler, Dimitri, Patty, and very close working relationships with Zmanda, sharing what was on our roadmap. They would listen to us. We'd give them input based on our customer feedback. So what I'd like to do to introduce this morning, so please join me giving a warm welcome to Chandler Kent, the CEO of Zmanda, who's going to talk about how they've built radically simpler backup and recovery.
Good morning, everyone. It's a privilege to be here. So it's interesting to come here right after Facebook presentation with a backup talk. And last year they stuck me after YouTube presentation. So I guess what I'll try to do in next 20 minutes or so is to talk about a few things which will help you save time and energy so you can spend more time on Facebook and YouTube. And actually I see quite a few faces who were there in my presentation last year as well. And if you are braving to be attending my talk 2 years in a row, you might as well laugh at my jokes this time around. Okay, so let's talk about what is at stake here. So we read a lot of analyst and press reports, and actually these used to be more prevalent before Sun acquired MySQL, and they would talk about how MySQL is getting this huge adoption at the web tier and not so great adoption on the back end, maybe on the financial and billing data, and some sort of implication being that somehow this web tier data was less important for businesses. Well, what this analysis fails to realize is what is contained in this web tier, in these web tier applications. What is contained is what I call customer-facing data, and this data tends to be at least as important and sometimes even more important for most organizations than their back-end data. Think about Facebook losing 1 million profiles someday. Orkut and MySpace are just one click away. Think about Ticketmaster losing information about their customers, along with 200 of their frequent flyer programs in their profiles. It will be a havoc for both Ticketmaster and its customers. So today's data protection challenge squarely lies in customer-facing data. And one of the reasons is that underlying technologies that power customer-facing data have changed very rapidly in the last few years, including the MySQL database itself. So system administrators and MySQL DBAs need to keep pace with all this change and craft a well-functioning backup solution for this critical data. The rate of change can be enormous. We heard about, what was it, 4 million users, 4 million new users, or 1 million new users in 4 days or something like that. And, maybe one of these days your application might reach that level as well. So how do you plan for that level of growth? Not only the data is important here, metadata is important as well. So, for example, business planners like to see what is the pattern of usage of users on the website. Maybe they will track what white papers are getting downloaded and based on that craft good marketing and sales tactics for the next quarter. So it's not just the customer-facing data, but also the metadata around it that is mission critical today for most organizations. And protecting this customer-facing data got to be one of the most important tasks of any DBA. I would say much more important than squeezing extra 10% performance out of the database. So one of the not so happy things of being in a backup company is that many of our prospects come to us after they have recently lost some valuable data. So they tend to be pretty cranky set of folks when our sales guys are trying to make deals with them. So we can obviously share some interesting stories about how our prospects lost their MySQL database. But instead what we did was we just went onto the internet and looked for some brave souls who wrote about what happened to their database on their blogs or on forums. And these are verbatim collected from the internet. And these range all the way from some poor chap just miswriting a SQL statement and deleting more than what they wanted, to a very standard, I lost my database during an upgrade or a migration. This tends to be, by the way, very, very common. Or another DBA who laments about, finding out that their homegrown MySQL backup script stopped working. Unfortunately, they found it one day too late. Also, the lesson learned at the bottom is also verbatim from one of those folks. Again, probably someone who is wiser after taking one hit too many. So now you are planning for MySQL backup. What are the top considerations? I will talk about the top 4 on this slide, and I'll talk about the most important one in a couple of seconds. So the first one is performance. So when we say performance, we mean actually 2 things. We mean what is the impact of backup on your production application, and this tends to be a key design factor, because what you don't want to do is impact your production application in a way that your business users force you to stop taking backup as often as you want. And there are 2 types of impacts here. One is the impact of sheer copying of data while backup is going on, physically copying the data from one location to another. The second impact, which in case of MySQL can be more crucial, is the impact of the lock, impact of the read lock on the database in order to do consistent backup of your database. So you need to look out for both. The other performance aspect is what happens during recovery. And there are 2 considerations here. One is how fast your restore needs to be at recovery time. So what is the tolerance of the business application at the time of recovery? Can you wait for 1 day when you recover your data, or does your data need to be recovered in 5 minutes? And there are trade-offs both ways. The other consideration is how precise your recovery needs to be. Do you need to recover to an exact transaction, or can you afford to lose few records which were updated before a disaster? And depending on your application, you may have different answers. So for example, maybe in an e-commerce application, you want to be able to recover to a precise transaction, whereas if you are running a blog which is being powered by MySQL, you may be okay if last 3 or 4 comments are lost after a recovery. And again, depending on the answer you get, you will have different strategies for your backup. The other 2 considerations are basically whether your backup solution is going to grow with you, whether it is going to scale up as you go from your current, let's say, tens or hundreds of gigabytes to a terabyte next year, and maybe who knows what in subsequent years. And there are two things to note here. One is that your data will grow organically as your business grows or as your application grows, but also regulations and compliance will come into play here, and you may be forced to keep your data for longer and longer periods. And combination of these two factors may mean that your data actually grows faster than what you originally planned for, or what even your business users are thinking about. The other side of scaling is scaling out, as I'm sure most of you have seen in your own organizations, that MySQL tends to scale a lot horizontally. Even in our own modest IT infrastructure at Zmanda, at last count, we found more than 15 production instances of MySQL running both inside and outside our firewall. So you want a backup solution which will scale out along with your MySQL database. And finally, what you are protecting tends to be the most prized data of your organization. And it has been reported a few times that so many of the targeted security attacks go after the backup infrastructure, because that is one place where an attacker can get most of what they are looking for from your organization. So you want to make sure that whatever you are backing up is as secure as possible. So not only does your backup solution need to scale up and scale out, but it also needs to scale across technologies. It needs to scale across lots of different ways of implementing MySQL today as well as future. So just in this conference we heard about the Kickfire SQL chip from Raj and his team. We also heard about Maria and DB plugin addition. I'm sure I can almost guarantee you that by next MySQL conference we'll hear about things that have not been even conceived today. So your MySQL backup solution, whatever you implement, needs to be flexible enough to incorporate opportunities and challenges posed by these various teams. So each one of these teams will come with a new set of challenges, but they may also provide an interesting opportunity to back up your environment in ways that you couldn't do before. So as an example, let's say you are using MySQL replication in your environment. This actually provides a very interesting way to back up your data without impacting your primary instance or your master. What you simply do is you get your slave to pause the replication, send a signal to the master to pause the replication, do any sort of backup on the slave, and then send a signal to resume the replication. So that hence doing backup without impacting performance. On the flip side, let's say you are running a MySQL cluster. Now you are posed with a challenge that you have all these nodes where a single database is flying around, and you want to be able to back up all these nodes to a central location so you can restore sanely from it. So how do you back that up? Now, I talked about 4 important considerations in my previous slide. The most important consideration when you are designing your MySQL backup solution or implementing your backup solution is how easy the restore is going to be. If you are sitting with your MySQL database down, especially when it is a data loss scenario, you will be surprised how many people suddenly became aware of your existence. So you will get so many calls. You will be doing recovery in a scenario which is far more tense than when you are, let's say, testing your recovery. So you want to make sure that there are as few flying pieces as possible at the time of recovery. Okay, so at Zmanda, our focus is to make backup and especially recovery as simple as possible, and indeed make it radically simple. And having a tagline like this helps with ego of our developers as well. So what we have done is we have created a browser-based console which makes configuring your MySQL backup as easy as answering these 4 questions. What do you want to back up, as in what databases, what tables? Where do you want to back up, as in what is the destination of your backup archives? When do you want to back up? Do you want to do full backup every weekend? Do you want to do a full backup every night? Do you want to do an incremental backup every 5 minutes? And how do you want to back up? Do you want to turn on encryption? Do you want to turn on compression? And once you have answered these questions, you click on activate, and your MySQL your backup implementation is ready to go. And we have done all of this using modern Web 2.0, Ajax and PHP style technologies, making our console friendly to all browser friendly devices, including the iPhone. So what that means is that you might be at your favorite vacation spot and you are notified about loss of some file, and you can recover without even leaving your cabana. Alright, so I will wear my sales hat here. I guess I've been wearing it for the last couple of slides now. So the product that I've been talking about is the Vendor Recovery Manager for MySQL. This is the comprehensive MySQL backup product that Zamanda sells, and actually is also available through Sun's Salesforce. This product basically enables you to back up MySQL database regardless of the configuration. You can do a backup of your local MySQL database, a remote MySQL database which might be sitting in your service provider's data center, or a set of MySQL databases which are spread across various places, including nodes of a MySQL cluster. All of that consolidated into one place. The most important feature of this product is recovery. We basically enable you to recover to any point in time of your choice. So regardless of what backup method is used, and this product, by the way, is aware of 30 different ways of backing up MySQL. And we pick the method, the best method which is specific to your particular implementation. We look at what storage engine you are using, we look at what is the underlying storage platform, what is the operating system, and based on that we pick the best backup methodology for you. In the upcoming release of ZRM, which our developers tell me is within next 4 weeks, we will support continuous data protection for MySQL as well. So one interesting thing that has happened in the backup world in last year or so is emergence of storage as a service. And this is, I think the leader in this space is Amazon's S3 service. And this is very different from backup as a service, which is, for example, provided by vendors like Mozy, which is now part of EMC. So what a service like Amazon S3 allows you to do is to treat it as an alternative to your removable medium. So instead of backing up to tapes and then getting a truck over to your organization to pick up those tapes, you can back up directly to this online S3 grid and recover from it anytime. And so Zamanda's products basically hook up to this grid, and you can back up your data directly there. There is a big difference between using something like an Amazon S3 grid as your backup platform versus using something like a Mozy as your backup environment, because the second one represents a closed source, a closed way of talking to a remote data center, and the only way you can get to your data is by using their service or using their application. Whereas Amazon S3 and such class of storage as a service represent a very open and standard way of getting to your data. So you can get to your data no matter what, even after a few years, regardless of whether you are using our products or not. And this is a strong principle that we have, that you can get to your data no matter what. And other benefit of doing this is that a small business owner can get the benefits of fault tolerance of Amazon's data centers. On first day, I don't know if you attended Werner's keynote, he talked about all the investment that Amazon is doing to make their data centers more robust. You get to take the benefit of those investments. Let's talk about some real life scenarios here. So one of the things that we get asked for a lot is this. I have a 100 gigabyte database which is growing into terabyte. I have a 24/7 application which stores customer facing data. The workload is OLTP, so updates are flying all over the place, and I want to be able to recover to a specific transaction. what is the best solution for such environment. There are, as I said, there are tons and tons of different ways of doing MySQL backup. Our own product is aware of 30 of them. What I believe today, the best method is using storage level snapshot for full backup, using MySQL binary logs for incremental backup. On top of that, if you can add an automated point and click restore, you have a perfect solution. I think I'll quickly share these numbers, as I think I may be running out of time. So we ran a benchmark last week actually on Solaris 10 on an AMD 64 platform with ZFS. Running MySQL Enterprise 5. The underlying platform supports approximately 500 gigabyte an hour kind of speed, so it was not a super optimized I/O platform. We basically got a box from Sun and put it in our data center, did a baseline, and we said, okay, let's compare against this baseline. And we ran ZRM 2.1 obviously as the backup. So first thing that we observed, so we did two types of backup. We did logical backup, as done by MySQL dump, and we did snapshot-based backup as supported by ZFS. So here the interesting thing is that logical backups obviously are more flexible. They allow you to do a lot more things with the backup archive itself. However, they are more expensive from timing perspective. So it took approximately 20 hours to back up a terabyte. Whereas snapshot-based backup basically scaled along with the copy speed. So 1 terabyte was backed up in little more than 2 hours, which was basically the underlying copy speed of the storage system. What is more interesting here is look at what happened on the logs. So we kept a read log throughout while logical backup was going on. So read log was kept pretty much for those 20 hours. Whereas in case of snapshots, going all the way from 1 gigabyte to 1 terabyte, our log time was below 1 second. And this is with moderate amount of load. So basically this scaled extremely well. So why do you use snapshots? They scale extremely well as your database grows. You need to use snapshots very carefully. There you will find instances on the internet where people will say, hey, I did a snapshot-based backup. I didn't bother about locking. I was able to recover fine. Don't do it. Read lock is there for a reason, and a sub-second read lock is not worth taking the risk. You will be playing Russian roulette with your database if you don't do so. So the other crucial thing is that you don't want to be recovering 2 years last snapshot. What you want to be recovering to is some point between those two snapshots. So you want your backup solution to integrate snapshot-based full backups with log-based incremental backups. Okay, so in terms of various snapshot technologies, these are some of the recommended ones. I guess that is another way of saying that these are the ones that our developers have gotten around to supporting, but these are definitely the key ones. I actually asked Paddy, our VP of Engineering, to give me some interesting factoid about snapshots. He just SMS'd me before this presentation that ZFS supports 2 to the power of 64 minus 1 snapshots per volume. I SMS'd him back that I'm really bummed about that minus 1. But 2 to the power of 64 snapshots per volume, that sure beats 255 theoretical maximum of LVM. So I guess what I'm saying is, who is +1 for ZFS on Linux? All right, Martin, maybe you can take that message back to Jonathan.
I will.
Okay, so in terms of backup and in terms of recovery, Zamanda Recovery Manager provides you with an extensive visual log analyzer. All you do is you pick the event that you want to recover to, and you click restore. It will throw you to the recovery screen, and it will automatically collate full backup and incremental backups for you, so you don't have to do all of that by hand. One slide on Zamanda. We are the leader in open source backup. I think Zach provided a very gracious introduction. We are based around a community called Amanda, which is the most vibrant open source backup community. In fact, our other product is called Amanda Enterprise, which basically helps you to back up an heterogeneous set of systems onto a central backup platform. What we are strong believers in is open formats, open standards, and open source. And we think that these three things come in triplets. If you have a 6,000 page specification document with a proprietary only implementation on top of it, that does not give you open format, because that 6,000 page document is open to so many interpretations, and these interpretations will get hidden in this proprietary code that nobody else will have clue about. I'm sure some of you are aware of what I'm talking about here. Locking up your backup data in a proprietary format comes with huge cost and pain. This cost and pain is in two forms. Let's say you use a proprietary software to write through a tape. You want to recover from that tape 7 years from now. 7 years, by the way, is compliance requirement for public companies in US for many kinds of data. Not only do you need a license from this vendor 7 years from now, you actually need a version which is pretty close to what you have today. So you have this huge maintenance issue. The other cost, by the way, is that now you have all this data that you have been storing over the years, which is sitting in some proprietary format, and you cannot do anything with it other than restore. This is such a bad use of that resource. You could use this data for running a very interesting data mining application, for example, or looking at how your organization has been dealing with various issues. You can unlock a lot of this value that is sitting in this data by storing it in an open and standard format. So at Zamanda, we believe in making backup and recovery of customer-facing data as simple as possible. We think that most organizations invest their best resources in customer-facing activities, and we are proud to be associated with keeping the data that powers those activities. There is a standard, logo slide. Our products with their simplicity yet feature-rich have found a very good audience. I will very quickly focus on one of them, Amazon's Mechanical Turk. This is an awesome project. If you have not looked at mturk.com, you should go and check it out. Basically, what it allows you to do is to create a project and distribute it into lots of different pieces and let other people, distributed workforce throughout the world, take a stab at these pieces that you have created. A very interesting project that I saw recently was a project called 10,000cents.com. At your leisure, look at how they used mturk to accomplish what they did. But the point here is that basically you have all these tasks on their website and all these users, which creates huge amount of activities with a lot of transactions, which is obviously something that they wanted to protect, and they obviously use MySQL database underneath it, and in addition to Zamanda Recovery Manager, they also back it up to Amazon S3 Grid actually by using Zamanda Recovery Manager. So that's, I guess, a vote of confidence from Amazon on their S3 service. Okay, now I will come to the most interesting part of my keynote. Very quickly, I do want to say that we have been very pleased to see the reception that Zamanda has gotten at this conference, and we do sincerely hope that you will trust us with some of your prized data. And let me invite Ann Rookstool, who is our VP of Sales and Marketing, to the stage, who will help me with raffling those guys. And those guys are another instrument for you to do live snapshots, which is basically a Canon SLR camera, along with highest end compact flash card available in the market today, which was gracefully donated to us by Lexer. As was mentioned in the previous presentation, flash and solid state with their reduced prices and bigger sizes are becoming a good alternative. We will. You had to fill up a form.
Take my dog back then.
All right. Okay. So I think that was the plug for Lexer. I will. So Anne, yes.
Back a locker?
I told him that Sun and Zamanda employees are not eligible. Who's next?
Okay, yeah.
All right. Anita Aoyang California Digital Library. All right.
Okay, so here's the camera flash memory and the high-end Canon SLR digital camera.
All right. Thank you, everyone.